Hey, what's up, fellas? What we're looking at here is a 12-volt positive displacement hydraulic pump. It's made for intermittent use, but I bored some cooling holes in there, and I'm just curious to see what we're working with here because it doesn't behave like a gear pump. The fuel delivery is too pulsy, and that would explain it. This is an actual G-rotor hydraulic pump. That's pretty impressive. I was not expecting that. Very cool. However, for waste oil burners, this pulsation effect shows up into flame like you wouldn't believe, and it could even cause some very undesirable operating characteristics. So, to shore that up, there's a lot of techniques. An accumulator is the best bet, though. That's what this thing right here is. It's just a little air tank that's hooked up to the airline, and wow, does it make a huge difference. Some of you guys have seen this before. I tried to do this test the other day, but it turned into a PID video. And I don't want that. But there's a quick contrast of the difference between an accumulator and no accumulator. This here is another cool little pump. I was pumping some oil out of my little oil bank here, and I decided to give this little diaphragm pump a try, and I was very impressed with how well it pumps oil. We're looking at about 230 kilowatts here. You can see here it's getting interrupted by air bubbles, and that's because I don't have a hose clamp on the intake line. The subtlest of vacuums can cause that. You see here now I have a hose clamp and it's working properly. So just by putting a hose clamp on everything on the intake stops those tiny vacuum bubbles from getting in there, and they become 10 times as big once they hit the vacuum. So now we got a perfect even flow. The only thing is I don't know how durable these diaphragms are. I went ahead and metered this flow because I was very interested in how smooth it was, and it came out to be about 231 kilowatts or 23 liters per hour is what we're pumping at. This is a burner I'm working on. I'm going to try and give this electric ignition a try tomorrow as soon as it stops raining. Just thought I'd show that to you guys. So that's another test that's going on along with the oil preheat system, which I don't think is going to work out too well. You can see here we've got a nice smooth flow, and the oil burners love that. They can handle that just fine. But the second you start pumping 500 watts in there, we start to either boil moisture or trapped gases or whatever it is. But the oil itself begins to boil in there, and we get some bubbles that do not recondense. So it could just be trapped gases in the oil being liberated by the heat. I don't know. But we're definitely not able to get up to the 300 degrees that I had in mind. However, the pump or the burner that we're using is a little bit unique, so it might be able to handle this. So we're going to be hooking this burner up and trying the electric ignition and all that stuff tomorrow. I just had to get the equipment calibrated, and I sure am glad I didn't do this out in the blowing wind. So I'm just going to try and dance these valves. I'm going to increase the pressure here a little bit by closing this main valve. I'm going to reduce the flow drastically here. Well, it's still flailing out of there quite a bit, but you see, I'm maintaining a small amount of pressure there. And now look at how small of a flow I'm able to get. So to control the flow rate, we're simply closing this valve off. And let's say we wanted to reduce that pressure a little bit. Let's say we decided that was too high. I would just simply open the bypass valve a little bit more. Because in some cases, on a high pressure pump, this could have like 500 PSIs in it. That is a really nice low flow. That's probably about 80 kilowatts of power right there. So that's how the bypass valve works. To reduce the flow rate of this pump, we take some of the discharge
and loop it right back into the intake of the pump. So it's doing this continuous loop. And what we do is we gate that flow with this valve here. This is the bypass valve, and this is the flow rate valve. By opening and closing this, we can increase the pressure and decrease the flow rate. But if you want to decrease the flow rate and increase the pressure, you close both valves at the same time. I'm not a fan of this motor. Real nice steady flow of fuel. I'm into it.